So it's just a quick introduction to this worksheet if you're trying to figure out how to do simplifying radicals. It would be best actually to go back to the notes page or notes paper video, Cornell Notes, to get a better overview on simplifying radicals. But if you want to get started on this worksheet, I'll give you a little bit of help in terms of getting started. So what I'm going to do here with the square root of 12 is I'm going to look for factors of the square root of 12 that are perfect square root numbers. I know that the square root of 4 times the square root of 3 is equal to the square root of 12. And again, you'll need to go back to the notes on this if what I'm doing right now doesn't make a whole lot of sense. So go back to that video if this isn't making sense. All I'm doing is factoring the square root of 12 into factors, one of which I know is a perfect square root. I know what the square root of 4 is. It equals 2. So my solution for this would be 2 square roots of 3, because this equals 2. Square root of 4 is equal to 2. I don't know what the square root of 3 is exactly, so I would just leave that alone. And that's the idea of simplifying a radical into its simplest radical form. It has the smallest possible root as a part of the solution. So it means there's 2 of these. The square root of 12 is 2 square roots of 3 as an equivalent. So as I look at the square root of 18, do a couple more here, just again as an introduction to this worksheet and the idea of simplifying radicals. The square root of 18 is the square root of 9 times the square root of 2. In other words, 18 is 9 times 2. And what I'm really looking for are things like 4, 9, 16, 25, 36. I'm looking for numbers that these are the factors of. Because if I can find a factor that's one of these perfect square numbers, then I can actually solve part of this. Like the square root of 9 I know is equal to 3. And the square root of 2 I don't know. And so by doing that, I have now simplified this. It has the smallest possible radical as a part of the solution. So the square root of 18 is equal to 3 square roots of 2, which is actually a distance on grid paper if you look at grid paper. Square root of 48. So again, I'm looking for factors of 48. Now I know 4 is a factor of 48, but I'm looking for the largest possible one of these. And if I don't get big enough, I can keep going with this. And so 49 is greater than 48, so I know it can't be bigger than 6. And 36 is not a factor of 25, but I know 16 is actually a factor of 48. So I could factor the square root of 48 into the square root of 16 times the square root of 3. And what that gives me now is a part that's solvable. The square root of 16 is 4. And a part that I'm going to leave as a radical, the square root of 3, because I don't know exactly what the square root of 3 is. So the square root of 48 is equal to 4 square roots of 3 in its simplest radical form. And again, the square root of 3 can't be simplified anymore, so I have it as simple as possible. It just means that this is 4 square roots of 3 long in terms of a distance. And so as you work through these worksheets, you're going to need this set of numbers for these perfect squares to be looking for factors of numbers as you go through them. So hopefully that helps you get started on this worksheet and continue on as you try to simplify these radical expressions.